Hi everybody, this is my first do-it-yourself video in English, and I hope it will help you to use optical fibers to collect sunlight. You can use this kind of collector to bring light in a dark room or even use it for your indoor plants. And it's all for free. This first part will quickly introduce some theoretical basics regarding optics and optical fibers. Then you will be able to adapt this tutorial to the supply you will have at your disposal. So, we have the sunbeams that fed a lens on the convex side. Then from the plant side, the beam will focus in one point, called the focal point. Two parameters are important when you choose a lens. Its diameter, d, and its focal length, f. We might think that the bigger d is, the better. But that's not the case. We will see later why. Let's talk about the optical fibers now. Every fiber has an injection cone. This means that if a light beam arrives in front of the fiber, only the ones that have a direction inside the cone will be able to propagate inside the fiber. If you want to have an idea of the size of the cone, you can feed the other side of the fiber with light. This way, to have a good optical coupling between your lens and your fiber, you need to have d equal to x and f equal to z. Now you understand that if d is too big or f too small, the light outside this cone will be lost. This also means you need to know the parameter of your fiber before buying the lens. Alas, x and z are almost never given for the fiber I'm going to use, so you need to measure it. Now we have the theory to build our light collector. For this prototype, I used small diameter lenses with D and F equal to 2 cm. I'm going to mount these lenses on several PVC tubes, and inside the PVC tube, the optical fiber will be held in place using a piece of wood. I will use several fibers per lens. This will help to increase the collecting time of sunlight. The final light collector will be composed of 19 small collectors with 5 to 10 fibers per collector. Here is what I used. The fiber is a very cheap one, often used to make a star sky in a bedroom, for example, or even to bring light inside a swimming pool. Adapt the fiber length to your application. In my case, it was just 1 meter per fiber, which is in the end good for this demo, but quite limiting for other applications. I also use 19 plano convex lenses with 2 cm of diameter and focal length, a 10 cm diameter PVC tube, 19 small PVC tubes that will hold the lenses, 19 wood cylinders that will hold the fibers and place them at the focal point. And you will also need some tools. Be very careful during manual activities. Children must be accompanied by an adult. Once cut, PVC or wood cylinders must be sanded down using emery paper, especially for the part in contact with the lens. The PVC tube must be longer than the focal length. In my case, they measure 3 cm. The diameter of the hole in the wood cylinder will define the number of fiber per collector. Using a lot of fiber increases the collecting time of the sunlight, but it also increases the weight of the device, so it's a compromise you need to make. In my case, I had 3 mm holes. Each wood cylinder must be inserted into the PVC cylinder using medium strength. This will allow to have a degree of freedom that we will use as a translation axis for fine-tuning of the collector. A very important point is the tip of each fiber. Usually they are not cut properly, so I had to cut each one of them. Indeed, an optical fiber with a bad tip will give poor injection and poor illumination. Here is the difference between good fiber tips on the left and bad on the right. This is how I cut them. I use the cutter. The fiber is placed on a wood board. Firmly press the blade on the fiber. You need to avoid to break the fiber. This step must be done without hearing a clack sound. Notice it took me a couple of cuts to get the trick. Each lens must be very clean. Use a soft cloth like the one used to clean glasses. I used a glue gun to hold the lens on each PVC cylinder. First, 1 pound of glue to place the lens flat side in contact with the PVC cylinder. Once the glue is dry, you can apply 2 other pounds of glue. Avoid excess of glue on each collector side, otherwise it might be difficult to do the final assembly. The fibers are all together with a tape, and once inside the hole made in the wood cylinder, they must not move. When they are in place, I used a small drop of superglue to hold them together. Then you need to tune each collector. Look as far as possible of the collector, translate the wood cylinder, and check the position of the fiber regarding the focal point. When they are magnified, like here, the setting is good. Don't hesitate to fade the other side of the fiber with light to help you during this tuning. Do the same for all of the collector. For the final assembly, glue together all the small collectors. You can now try your device on the sun and, if needed, do some fine tuning. I hope you enjoy watching this video. Please share and like it. This will help me to make more of them.